Here's a video that gives a solution for a timing diagram that illustrates the difference between flip-flops and latches. Okay, so first of all, let's identify which one is the flip-flop and which one is the latch. And what we know is this symbol right here is the symbol for an edge-triggered clock, and this lack of an arrow shape here shows that this would be the latch. So this is the latch and this is the flip-flop. Okay, so for a flip-flop, the flip-flop is edge triggered. There's no bubble on the clock. And so what we care about is what happens on the positive edges of the clock. All right, so in this particular case, QA is the flip-flop, so we're going to be reading the flip-flop value. We know it initially starts at 0. So the flip-flop acts like a memory, so it's initially remembering or storing the 0 value. And then when it hits this positive edge, it reads the input to the flip-flop, which in this case is X, and after a slight delay, we can draw that in as a slight delay, it would go high. And it's going to stay high until the next edge. On the next edge, we're reading a 0 here, and so then it would go low, stay low till the next edge. There's still a 0 on the next edge, so it holds that 0 to the next edge. Then we see we go up to a 1. It's going to hold that 1 until the next edge. Then it reads the 0 and comes down. All right, so there's the timing diagram for the flip-flop. Okay, so for the latch, it's a little more complicated because the latch follows the input during the high portion of the clock, when the clock is a 1. So what I can do here is I can go in and highlight the part of the clock. So all in here, the clock is enabled. And the latch is going to follow the data during the positive edge of the clock, or the positive cycle of the clock, not the edge. And then it will hold that value as we make the transition out of the positive pulse of the clock. All right, so I've drawn all those in. And so what I can do from here is I can draw this in, and you see it's going to hold the 0 until I get the positive pulse of the clock, and then it's going to follow. It's following the data during here. As it leaves that positive pulse, it's a 0, so it's going to store that 0. Okay, it's going to follow the data in the positive edge of the clock. As it leaves that positive pulse of the clock, it's going to store that value. Okay, and in here, it's going to follow the data and then hold it, latch it, follow the data, latch it, follow the data, latch it. Okay, so that's how you do the timing diagram for a flip-flop and for a latch. You see you get different output signals because these are different devices.